Hello, we are Group L18. We are the Advanced Analytical Identification of Turbine Components working with Siemens Energy. My name is Christopher Flannery. I am the project manager. I also worked on database and hosting.
My name is Milton Joseph. I worked on the API and the front end.
My name is Pranav Nair. I worked on the OCR and backend.
I'm Samuel Bauta and I worked on the front end.
My name is Daniel Rodriguez and I work in the front end.
So Siemens Energy currently employs a process that needs to take less time and improve organization to help prevent loss. The turbine components that they use are currently tracked using serial numbers and style numbers that are manually recorded by one individual and then later entered to a datasheet pertaining to each outage location. We're seeking to aid in this process through our application, which will allow users to identify the same components using the same serial numbers, add them to the required datasheets, and then allow them to export these datasheets in CSV format. Our expectations from Siemens Energy was that we create a mobile application, that they want the data to be exportable at CSV format. They want 2 or 3 solutions to have for capturing data, that including barcode, voice dictation, or AI, though AI is a required feature in this application. And then, of course, they want the application to be quick and easy to use. For our design, we chose to use YOLO V8 for our object detection, Swift for our mobile application, including the barcode scanner and natural language processing, Flask for our API, MariaDB for our database, both of which will be hosted on our Ubuntu server, and which will also host our image repository and our email system.
As for the mobile application, we went with Swift since it's Apple native and it was very quick and easy to use. As for the barcode scanner, we decided to use the Apple Vision Framework, which is also Apple native, and it's very efficient scanning any sorts of barcodes. And for the image analysis, our main 2 things that we have, it's the OCR and the barcode scanner. For the OCR, we incorporated YOLO V8 object detection technology. We're able to send images to a server for processing throughout custom trained YOLO models. As for the barcode scanner, like I said, we utilized the iOS native capabilities for barcode scanning, voice detection, and manual input. And as for the API, we use the Flask API to allow us to retrieve and send data to a server. And for the UI UX design of choice, we personalize the user experience. We use the colors of the company, which is this 3 white, blue, and purple, as you can see right here. It's very simple and it's just a streamlined approach. This is our homepage. It's just one button and it takes you to the outage for the part types. And in the part types, you're gonna have a sheet with that connects to the server, and you have all of the different outages that you can select from. Once you select your outage, it would take you to the next page, which is very similar. And here you're gonna select your part type. So to make sure that you know which part you're scanning, and then it's gonna ask you either 2 options, either to use a camera, which is the OCR feature. You either take a photo or you select it from your camera roll, or if you want to just use the regular barcode scanner, which is very direct, you would use the scanner.
Then once you, if you select to take a photo, you can pick from your photo library if you already have the images of the serial numbers that you want. Otherwise, you can go and take a photo manually if you want to do that as well. If you choose to take a photo, it'll send the photo to the OCR model for processing. And then if we choose to do the barcode option, the app will let you know when a barcode has been detected. And once you click next, it will populate that barcode into the barcode results on the verification page. Once you're in the verification page, if you use the OCR and you get 100% match, the result will automatically populate. Otherwise, if there was not 100% match, you'll get returned the 5 closest matches to whatever the model thought the result was. If you don't choose to use either of the barcode or OCR methods, you can always enter it in manually, or you can either type in the result or use the microphone for voice dictation. After you verify all the information, you'll hit the confirm page where you can enter your email for exporting as a CSV if you choose to export. Otherwise, you can always scan more. This is how the data looks if you choose to export it. And if you choose to just continue scanning parts, it'll also take you back to the part type page. Otherwise, if you choose to export and you're done, then it'll just take you back to the home page.
For the OCR or optical character recognition, we decided to use YOLO V8 because the images and the characters that we were dealing with at Siemens Energy, because they were on turbines parts, we had to use a more complex algorithm because most OCR models are trained on regular black and white text, but since we have more diverse set of images, we had to use a more complex object detection algorithm. So YOLO V8 is a deep learning based object detector, and it's usually used for detecting different objects as seen in the image below. You can see it's detecting cars, people, and buses, etc. But in our case, we trained it so that it would distinguish between different characters and identify them and put them together as a string, so that we could further export them to the Excel. This is a set of our results. From initially, we had around 200 images, which we trained them on, and we defined all the boxes for these. And each image had like 8 to around 15 characters. Using all of them, we trained the model, and these were the results that you can see are mostly correct.
For our API, we chose to use Flask, which was inherently simple. It allowed us to get started quickly and define our 4 endpoints, which are get outages, OCR, add to datasheet, and export. We'll show you our sequence diagram, which you can see the interaction between all parts of our application, but the main part for the API was sending the request for outage information to the server, sending the image for OCR, sending the data for addition to the datasheet, and sending the request to export the CSV.
So for our database, we decided to actually move to a database instead of just using Excel sheets and CSVs. We looked at MongoDB and MySQL, but neither of them were as powerful or as useful as MariaDB. So MariaDB is an improved version of MySQL. It worked in Python, which was great for our backend, which is completely written in Python. We could move all of our Excel sheets into tables, and we can directly export to CSV. And with the foreign key constraints of MariaDB, we allowed for data verification at the server level. We also had a fuzzy search, which we talked about earlier. So if the OCR comes back and they do not have a 100% match, this will find the 5 closest matching strings that we found in the database. And our assumed runtime with around 3 million entries is still less than 1 second. So for our server, it's self-hosted from my personal home lab. It runs the YOLO V8, the MariaDB, Flask, holds our image repository and our CSV repository, and allows for our email functionality.
For our feedback implementation, we had feedback from Siemens Energy as well as from our professor. The colors and the flow of the application mostly were dictated by Siemens Energy. And then the suggestions from professor were persistence of data between scanning parts, whether that be outage information, part type, or our email, and the fuzzy search, which helped us improve our OCR accuracy.
Thank you very much.